Hi, in this video, I'm going to be solving this equation with factorials. I'm not sure where the origin of this equation is. Someone sent it to me, but I think it's either a homework problem or some sort of a training problem for a math team or math contest. But I like it because it illustrates two things in this line of questions. One is the standard way of solving a factorial problem is you expand it out and you cancel as much as possible. And the second thing it illustrates is that sometimes for these kinds of questions where the answer is expected to be an integer, you reduce it down to only a few possible answers and then just like go ahead and just check them all. So let's go ahead and solve this. That we have this equation with the factorial of x minus 1 times factorial of x minus 2 divided by the factorial of x factorial, and the whole thing's supposed to be equals to 1/2. Now, they don't say it, but because the factorial notation only works with non-negative integers, so integers from 0 and up, and therefore x has to be an integer. All right, what's the definition of a factorial? A factorial n factorial is defined as multiplying all numbers from 1 up to that number n. So 1 times 2 times all the way up to n if n is greater than or equal to 1. Whereas for 0 factorial, we just define it to be equal to 1. So let's expand this out. X minus 1 would be 1 times 2 times all the way up to x minus 1. That's x minus 1 factorial. X minus 2 factorial is 1 times 2 times up to x minus 2. Divided by x factorial is 1 times 2 all the way up to x. But before we get to x, we have to go through x minus 2 and x minus 1 to get to x like that. So when we write it out like that, we can see that things can cancel. All of this 1 through x minus 1 can cancel with the x minus 1 factorial on top. And the whole thing is left with 1 times 2 times all the way up to x minus 2, which I'm going to put it back in its original form is x minus 2 factorial divided by x. So the left-hand side of the equation simplifies to just x minus 2 factorial divided by x. And this is supposed to be equal to 1/2. Standard thing to do when you have equation with fractions on both sides to cross multiply so you don't have to deal with fractions. If and only if 2 times x minus 2 factorial is equal to x. All right, one of the things we know about factorials is that because we're multiplying a bunch of numbers together, it grows really fast. It's one of the fastest growing functions out there. This x minus 2 factorial will grow really fast, whereas this x function grows slow. If x is any kind of large number at all, this is not going to work because you have something that grows really fast, so it gets big really fast. You multiply it by 2, it's going to be a pretty big number, whereas this is just x. It's not going to be that big. So I know that this is not going to be big, so I'm going to try something. If x minus 2 is equal to 3, then this is 3 factorial times 2. So if x minus 2 is equal to 3, then this expression is equal to 2 times 3 factorial. And 3 factorial is 6, so 2 times 6 is 12. Whereas on this side, if x minus 2 is equal to 3, then x is equal to 5, and 12 is greater than 5. And then since factorial grows fast, if it's already 12 greater than 5, then the next number is going to be even bigger. So there's no way x cannot be greater than or equal to 5. There's no way any larger number will work. That means x has to be between 0 and 4. That's only 5 numbers. We could just go ahead and check all 5 numbers now, but we have another elimination, and that is x minus 2 has to be at least 0 in order to have factorial. That means x has to be greater than or equal to 2, and therefore we really only need to check for x between 2 and 4. Number 2, number 3, and number 4, 3 numbers, so might as well just check them all. So I'm going to check this. 2 times x minus 2 factorial. I'm going to check for x equals 2, 3, and 4. When x equals 2, this is 2 times 0 factorial, which is 2 times 1, and that is equal to 2. That is equal to x, so I'm good. When x equals to 3, I have 2 times 1 factorial, and that's 2 times 1, which is equal to 2, so that's not good. And when x equals to 4, I have 2 times 2 factorial, which is 2 times 2, which is equal to 4, so that's good. So I have my 2 solutions. Box it up. Let's check with the original equation. For x equals 2, the original equation would be 1 factorial times 0 factorial divided by 2 factorial, which is 1/2. And for x equals 4, 3 factorial, 2 factorial divided by 4 factorial, which is 6 times 2 divided by 24, which is also 1/2. All right, that's this problem, and it illustrates this. The last part of it illustrates that sometimes you can reduce it down to just a few possibilities and then just brute force check them all. The beginning part of this problem illustrates that when you have a question with a bunch of factorial, it's always a good idea to try canceling a bunch of them out. All right, hope that helps. Like, share, and subscribe for more contents, and thanks for watching. Bye.